Welcome back. Let's see vector class. This vector class is implementation of the list interface, which means whatever the features that are available for the list interface, those are all the features are supported by the vector class, right? So basically this vector class internally uses dynamic array, means based on the values the user is adding, it will increase its array size. Means array is not fixed in size, it is going to be in growable in nature, right? So what the default capacity of the created dynamic array means? The default capacity is 10, right? The same concept you have observed in ArrayList also. ArrayList is a kind of a class which is the implementation of the list interface. All the features that are supported by the list interface will be supported by ArrayList. It internally uses the dynamic array which is global nature, whose default capacity is 10. But what is the difference between the vector and the ArrayList classes, right? One difference is, once the threshold is reached in the ArrayList, it is going to increase its size by 3n by 2 plus 1, right? Hope you remember this point, right? If you come to the concept of vector class, once it reaches to the threshold value, it is going to increase its size of the array by 2n. Means earlier, if you are going to have 10 elements, something like 0, 1, 2 and so on, 9, 10 elements. If some threshold value is reached, then it is going to increase its size by 10, which is 20, 0, 1, 1, so on, 19. Next, if the threshold value is reached, it is going to increase its array size by 20. So 2 into 20, that is 40, which is 39 index position. Like that, vector is going to work. Whereas coming to here, if the initial capacity is 10, then 3 into 10 by 2 plus 1, which is 16. Next, so which means it is going to create an array of size 16. If the threshold value is reached, then it is going to be 3 into 15 by 2 plus 1, which is approximately 23. Like that, it is going to increase. This is one of the difference what you can observe between the vector and the ArrayList, right? And one more thing is, which is important one, ArrayList is not synchronized. ArrayList is not synchronized, where vector is going to be synchronized. Means in a multi-threaded environment, ArrayList should not be used, because when multiple threads are trying to use the same ArrayList, the ArrayList will allow to use them parallelly. When they are going to use them parallelly, it is going to produce unexpected results. But coming to vectors, as these are synchronized, at a particular point of time, only one particular thread is going to allow to access the data. So the result is going to be correct one. This is one more difference between the vector and the ArrayList, right? As these are not synchronized, we can say that these are not thread safe. Whereas coming to vector, these are going to be thread safe, right? So if you say in multi-threading environment, as all the threads are going to allow to execute all the things at the same time, what about the execution? These are going to be a little bit faster, but it is going to be a little bit slow, right? So if we summarize all the points what we have discussed, if we try to write the difference between ArrayList and the vector, ArrayList internally uses dynamic array whose default capacity is 10, that we know. When it is increasing its size, whose threshold value is reached, 3 3n by 2 plus 1. Whereas coming to the vector, it is going to of size 2n. And array list is not synchronized in nature. This is the point number 2. Whereas coming to vector is going to be synchronized. As it is not synchronized, I can say that it is not thread safe, which means that whose results might be incorrect. Whereas coming to vector, it is going to be thread safe because only one thread is going to allow to execute at the same time. And as it is not thread safe, multiple threads are trying to execute parallelly. I can say that it is going to be a little bit fast. Coming to this one, it is little bit slow. So this is somewhat the differences between array list and the vector, right? Yes. So next we'll try to see, or before moving to the next one, stack, we'll try to execute the vector, right? How we are going to create list of integers data equal to new vector. That's it. Data dot add of 1, data dot add of 2, data dot add of 4. You can process it easily, right? This out of I can print the value data. If I run it, you'll get the values 1, 2, 4, which is same as ArrayList only purely, but the difference is what I have explained right now, right? Can I add the data at the particular index position? Yes. Data dot add of, what is the index position I have to add if you want to get the value 3 at the index position 2, 3. You'll get the value 1, 2, 3, 4. Like this you can able to work, right? So basically this vector is going to be used in the multi-threading environment. This is important one. Okay, hope you understood, right? Next we'll move with the next element, that is stack. Stack is a class which is extending the features of the vector, right? So basically if you look into the stack follows a principle. That principle is first in, last out. First in, last out, or I can say last in, first out. Means whatever element that are going to insert at the first, they are going to come at the last. I mean, if you look into a kind of simple bowl. Suppose for example, I am trying to place some biscuits here. Suppose each and every one biscuit it can able to place. If I put the first biscuit, next the second biscuit, next the third biscuit, next fourth biscuit, right? How I can get the data, get the biscuits outside of this bowl. I have to first pick the 4, then I have to pick the 3, then I have to pick the 2, then I have to pick the 1. Means this is what I can call it as first in, last out, or whichever thing is last in, that will become under first out, right? So this is the general principle of stack. And this stack is a kind of a subclass of the vector, which means all the features what are they will supposed to inherit into the stack. How we are going to create? Basically you can create with respect to the same as earlier, stack of integers s equal to new stack, right? So there are many number of applications are there with respect to stack. You can able to go through that, right? Something like you can able to order the element, reverse the elements of the list, or you can able to go for parenthesis evaluation, right? In one of the earlier videos, I have discussed how to evaluate the parentheses using the stack. You can just go through it so that you can get a clear idea, right? Now in this particular video, I will try to take an example how to reverse the elements, right? Basically, if you say a kind of a stack, we have to have various kind of operations, right? The general terminals what we are going to use in the industry. Something like push operation is there, which is used for to add the elements into the stack. Pop, which is used for to remove the elements from the stack, and peek is there, which is used for to know the top element of the stack. Like that, we have various kind of methods that are supported with the stack. I think isEmpty is there, which would for, so you know, isEmpty is a method which is available in the collection. It's available in the collection interface. So this particular method is supposed to be available in all kind of classes and interfaces. Suppose so isEmpty is going to be supported. So like that, we can able to use various kind of stack methods, right? So let's see with an example so that you can get clear idea, right? So I will try to erase this. So let me take stack of integers. Let me import this. Let me take as data equal to new stack. New stack, good. I want to add the data into the stack. Data dot push you have to use, right? Data dot push of 1, data dot push of 2, data dot push of 3. If I try to print the output, what you are going to get? You are going to get the output as 1, 2, 3. The order in which you have added, the same order you are going to get. But if I am going to apply data dot pop, what you are going to get? You are going to get the last added element, right? If I try to print it, you will get 3. The element what you have added at the last will get, right? For example, if I say data dot peak means what? Topmost element of the stack, that is again 3. Similarly, data dot is empty. Whether the stack is empty, your result should be false because it contains some elements, like 3 elements are there. So you are going to get the data as false. Hope you understood clearly. Thank you.